The understanding of the on-delay and off-delay operation is important because regardless of the timer you use, the behavior of their respective delay contacts will be the same. Let's start first by looking at the on-delay timer. As we mentioned earlier, the on-delay timer begins timing as soon as there's power continuity at its input. Once the timer has timed out for a specified time amount, their normally open time delay contacts will close. We can see this response even more clearly in the so-called timing diagram. When the input to the timer goes from off to on in an on-delay timer, the timer starts to time and its contacts will close after a specified delay. The delay contacts will continue on until the input to the timer is removed, at which point the timer will reset. Remember that the instantaneous timer contacts would have closed as soon as the timer input was energized and will reset as soon as power is removed from the timer's input. The normally open contacts of an on-delay timer are also called normally open, timed closed, because after the delay they will close. They are normally open and closed after the delay. The normally closed contacts, also called normally closed timed open after the on delay. Let's see. Before the input to the timer is on, the normally closed contacts of the timer will be closed. When power is applied to the timer starts timing, and the contacts remain closed and will open when the delay has elapsed. That's why they are also referred to as normally closed timed open, because they are closed and open after the time delay. When the input to the timer is removed, the normally closed contacts will go back to their normal state, which is closed. Remember that the symbol with its half arrow indicates the direction movement of the contact after the delay has passed. In this case, it went from closed to open. The off-delay timer contacts operate similarly to the on-delay, except that the timed contacts will open or close after the timer's input goes from on to off. If the input to timer is off and goes to on, the timer will be on and will start timing after its input is removed or off. After this delay, its respective delay contacts will react by opening or closing. The normally open contacts of an off-delay timer are called normally open, timed open, because they will open after the delay, as can be seen by the arrow in its symbol. Let's see how they work by looking at both its circuit representation and the timing diagram. Before anything happens with a push button not pushed, the timer contacts are open. When the push button is pressed, the time delay contacts will close and the timer will be on, but will not start timing the delay. When the input of the timer is off, because the push button is released, the timer will start timing the delay. The normally open contacts at this point are still closed. After the timer has timed out the delay, the contacts will go back to their normally open state, essentially resetting themselves. In the timing diagram, we can see this more clearly. Before the timer is energized, the contacts are open. After it is on, the contacts will close and stay on. When the timer's input is off, it starts timing, and after the delay, the contacts will go back to open. The off-delay timer's normally closed contacts, also called normally closed, timed closed, operate in a similar fashion. Remember that its name and symbol imply that these contacts will close after the delay has elapsed. Let's look at it in the timing diagram. When the timer's input is off and has not been energized, the normally closed delay contacts will be closed. When the timer's input is energized, the normally closed contacts will open immediately, just like an instantaneous normally closed, and will be open as long as the timer's input is on. When the input is removed and goes to off, the timer starts timing the delay. The contacts at this point are still open. After the delay, the contacts will go or reset to their normal state and close.